Hi, Assalamualaikum and a very good morning. So now we are in chapter 4, which is Introduction to Organic Chemistry. We're going to focus on the subtopic of 4.4, which is Reaction of Organic Compound, part 2 of this video. So in this video, we're going to look into the definition of electrophile and nucleophile, where electrophile is usually denoted as E+, means that it has less electron. Meanwhile, for nucleophile, it's going to be denoted as Nu and Nu minus, which means that it has more electron. Alright, and we're going to learn more about this later. Meanwhile, at the same time, we're going to look into the part D, which is explain the main type of organic reaction, which is we have addition, substitution, elimination, and rearrangement. So by using the concept of nucleophile and electrophile, we're going to explain these four types of organic reaction. So without any further ado, let us start. So electrophile is basically an electron deficient species. Deficient means less electron. So, electrophile adalah spesies yang mempunyai kekurangan elektron. And this electrophile will be attacked by the high electron density carbon by accepting an electron pair. Alright, because it has less electron, the more electron species, for example, alkene will attack the electrophile. Okay, electrophile got less. For the more highly electron density carbon atom, for example, butene will attack the electrophile. Okay, so high electron density carbon atom means electron rich area. So this one is electron rich, and this will be denoted as double bond or in the Benson ring. So it will attack the electrophile. So the electrophile here can be either a neutral or the positively charged species. For example, we have H+, H3O+, carbocation, Lewis acid, okay, and oxidizing agent. All right, so this is example of the electrophile in the table here. Next one, we have the nucleophile. Nucleophile here means that it is an electron-rich species. So, Nu minus, it is rich in electron. And it will attack a low electron density carbon atom by donating an electron pair to form a covalent bond. So, low electron density carbon atom means a positively charged carbon atom or the carbocation. Okay, so you know that nucleophile will have a very electron-rich species, so it will attack a low electron density carbon atom, for example, carbocation. So more electron will attack the less electron. Okay, an example of the nucleophile are anions, carboanions, Lewis base, or the reducing agent. Means that it is a species which have a negative charge or a species which have a lone pair. Alright, so a nucleophile can either be neutral or neutral, as for example the Lewis base, or negatively charged. Alright, so now we're going to look into the sites. Okay, tapak. Site in organic reaction can be classified as the electrophilic site and the nucleophilic site. Okay, so electrophilic sites mean that it is a molecule with low electron density around a polar bond. Okay, mempunyai kekurangan elektron dan dianya selalu berlaku dekat polar bond. For example, we have the carbonyl group. So you know that it is a polar bond, and oxygen here is more electronegative than carbon. So oxygen will pull the electron density towards itself, causing the carbon to be partially positive. Okay. Also, we have haloalkane. So haloalkane here, X gonna be halogen. Okay. So halogen. So example of halogen gonna be chlorine, fluorine, or bromine. So the halogen here is a very electronegative atom. So it's gonna pull electron density towards itself, causing the carbon to be partially positive. So here gonna have low electron density. Okay, and the other example is the hydroxy compound. So the same explanation as before, and this region here is the low electron density. Okay, so this is known as the electrophilic site, and this area gonna usually be attacked by nucleophile. So nucleophile which have a high electron density species will attack the electrophilic site. All right. Meanwhile, the nucleophilic site is a molecule which has a high electron density around the carbon-carbon multiple bond. For example, alkene. Okay, so dia bukan polar bond tau. Dia adalah carbon dengan carbon. But it has a double bond, which means that it has a high electron density. And we also have alkynes, which have a triple bond, so which have a high electron density. Okay, same goes to the benzene ring, because here refers to the carbon-carbon double bond, carbon-carbon double bond, and carbon-carbon double bond. So usually a high electron density will attack the electrophile. Okay, so what you can conclude here is that the nucleophile here will attack the electrophilic site. Meanwhile, the nucleophilic site will attack the electrophile. So it always need to be the partner. Okay, nucleophile with electrophile, and electrophile and nucleophile. Nucleophile and nucleophile will not react together. Same goes to the electrophile and electrophile. So one species need to have more electron, one species need to have less electron. Okay. So by understanding this, we're going to learn about the type of organic reaction. We have the addition, substitution, elimination, and rearrangement. So for addition, you're going to be divided into two, which is electrophilic addition and nucleophilic addition. For substitution, you're going to be divided into three, which is the free radical substitution, electrophilic substitution, and the nucleophilic substitution. Meanwhile, for elimination and rearrangement, there is no division. So it's just known as elimination and rearrangement. Alright, now we're going to look into the electrophilic addition first. So for the addition, it basically a reaction in which atoms or group of atom is added to the adjacent atom of the multiple bond. Okay, then bila ada addition ni, they're going to be producing only one type of the product. Okay, and as mentioned, there are two types of addition reaction, which is electrophilic addition and nucleophilic addition. So let us focus on the electrophilic addition first. So electrophilic addition, nama pun electrophilic. So it will be initiated by the electrophile by accepting electron from an attacking nucleophile. Alright, so this is the typical reaction for the unsaturated compound, for example, alkene or alkyne. Alright, as you know that alkene and alkynes will have carbon-carbon double bond, and alkyne gonna have carbon-carbon triple bond. So they have a lot of electron, and it gonna attack the electrophile, which is usually a positive charge or neutral atom. So let's say if you have alkene here, so the alkene here will have a very high electron density, and here Br2 here, as what you can see in the table in the previous slide, it acting as the electrophile. So here acting as a nucleophile, and here acting as the electrophile. So the nucleophile will attack the Br, and as mentioned, the double bond here gonna be a single bond where we adding the Br atom to the carbon here and the Br atom to the carbon here. So it's gonna be CH3, CH, Br, and CH2, Br. Okay, so the idea is that H, C, H, and H. So when it attacks the Br, so Br here will now be attached to this carbon, and the other Br here going to be attached to this carbon. So the double bond here going to be a single bond, and going to be a single bond here. Okay, and that is why it's forming something like this. Okay, and because electrophile are being added to the nucleophile, it is known as the electrophilic addition. Alright, now we're going to look into another type of addition, which is nucleophilic addition. So nama pun nucleophilic addition, so it is initiated, dimulakan oleh nucleophile, where the nucleophile attacks the electrophilic site. Okay, so these are the typical reaction of the carbonyl compound. Okay, for example, the CH3 C double bond O CH3. So you know that this is the polar bond, and here is more electronegative, so it will pull electron density towards oxygen, and the carbon going to be a positive terminal. Okay, so it's going to be electrophile, and the Cn here going to be the nucleophile. okay, as what you can see in the table, because basically it's going to be H plus and Cn minus. Okay, so the Cn minus here going to attack the electrophile, and this causes the addition of nucleophile into the system, into the carbon here. So the carbon-carbon double bond will break and it's going to attach the Cn. Okay, and the oxygen, the double bond here gonna take another hydrogen plus. Okay, so this is known as the mechanism, but at this point you don't have to know the mechanism. You can just directly say that Cn will be attached to the electrophile, and this is known as the nucleophilic addition, and that is why O will become OH here. Okay, now we have the substitution. For addition just now, we just adding the atom into the carbon-carbon double bond or carbon-carbon triple bond. But for substitution, the keyword here is being replaced. Okay, so a reaction in which atom or group of atom in a molecule is replaced by another atom. So kita tukarkan dia. Mula-mula dia H, tapi bila ada reaction, H tu akan digantikan dengan Cl. Addition, kita tambah. Okay, ada bezanya. So there are three types of substitution reaction, which is the free radical substitution, electrophilic substitution, and the nucleophilic substitution. So for the free radical substitution, it's basically a substitution reaction which involves free radical as the intermediate species. For example, if we have the ethane here, so CH3Cl plus Cl2. So as what you can see here, one of the hydrogen gonna be substituted into chlorine. Meanwhile, one of the chlorine here, ClCl, gonna become HCl in the product. Okay, so it starts with CH3, but now it becomes CH2CH3 because it is being replaced. Alright. Now for the electrophilic substitution, it usually happens for the aromatic compound. Okay, so as you know, the benzene ring will have a carbon-carbon double bond, right? So it will have a high electron density, so it is prone to the electrophilic attack. So for example, we have the benzene ring here. So the benzene ring here can also be drawn as carbon-carbon double bond. Sorry. And here. Okay, so here acting as electrophile. So the double bond here can attack the carbon-carbon double bond here will have a very high electron density and it will attack the electrophile. Okay, so when it attack the electrophile, it's going to be an electrophilic substitution, and the H here going to be replaced by the bromine. Okay, so it doesn't matter because the Br here is interchangeable. So you can draw whichever way that you want. For example, this side. Okay, so you can also eat from here and draw to here, and that is why you get your product. But if I draw from here, I will also get the same product because you can just interchange the cyclic. Alright, so because electrophile is being added into the carbon-carbon double bond, it's gonna be free electrophilic substitution. Okay, so the H here is substituted by Br. Okay, so it can be any hydrogen in the benzene ring. Okay, and to be more specific, it can be also known as the electrophilic aromatic substitution because it involves aromatic compound. Okay, now we go into the nucleophilic substitution. So for nucleophilic substitution, it's basically a reaction of saturated organic compound bearing polar bond as the functional group. For example, haloalkane or alcohol. Example, if we have the haloalkane here. So the haloalkane here will act as the electrophile, and the OH minus here going to be acting as the nucleophile because it has a negative charge. Okay, So the negative charge here gonna replace the Br here. Okay, so OH will enter and the Br will be taken out. Okay, and you will learn more about this mechanism in the haloalkane chapter. But for now, you just know that the nucleophile is being substituted here. So this is known as the nucleophilic substitution. Alright. Now we go into the third type of the organic reaction, which is the elimination. So elimination is disingkirkan, or it means that atom or a group of atom are removed, dibuang from the adjacent carbon atom to produce a double bond or a triple bond, which also known as the unsaturated molecule. Example, at first we might have alcohol. Now, when we undergo elimination via concentrated hydrochloric acid, concentrated sulfuric acid, and applied with heat. Okay, so here means heat, high temperature. You can see that the HOH is being removed from the alcohol in order to form alkene. Okay, the class of compound from alcohol into alkene because HOH, which is water, is being removed. Okay, and this is known as the elimination process. And the alcohol going to produce a new compound, which is alkene. Now we're going to go into the fourth main type of organic reaction, which is the rearrangement. So rearrangement is a reaction in which atoms or group of atoms in a molecule rearrange, which means that it can be changing position, reorganized in order to form a new molecule. Okay, so it can involve the rearrangement of the carbon skeleton. For example, a benzene ring attached with CH2, CH2, CH3, and then it will create another isomer of CH, CH3, and CH3. Okay, so basically it has the same molecular formula, but the rearrangement of the carbon skeleton is being different. Okay, it will be transferred there. Or it can be due to the migration of the functional group or the positional isomer. So as what you can see here, the chlorine atom is transferred to this side. So this is known as the rearrangement or the migration of the functional group. Or we will have the other type, which is the enol and the ketoenol tautomerism. Okay, so here you can see that it can be existing as a ketone or as a enol group, which is the carbon-carbon double bond and the OH group. So this is the example of the rearrangement processes. Okay, now we're going to do a few of the examples here. Okay, so we have to state the type of the reaction for each of the equation given below. So we have CH3, CH, OH, CH2, CH3 reacting with SOCl2. So SOCl2 basically provide chlorine in the reaction. Okay, so as what you can see here, OH is now replaced with chlorine. So you know that it is a substitution. Okay, pasal ada pertukaran, bukannya penambahan. So you know that it is a substitution, and chlorine here acting as the nucleophile. Okay, so chlorine will have Cl minus. Okay, so the Cl minus going to attack here, and OH will be removed out. So it's a nucleophilic substitution. For B, we'll be having a ketone H3C, C double bond O, CH3. Okay, now as what you can see here, the double bond become a single bond. Alright, and you know that when a double bond become a single bond, it is not being replaced. It is an addition reaction. Okay, so we know that it is an addition, but as mentioned, Cn here going to be Cn minus. So it's going to be a nucleophilic addition. Okay, now for the third part, we have a benzene ring, and then we have NO3. So as what you can see here, the NO2, because it might have NO3 here, but due to the mechanism, it will only attach NO2. Okay, so this will result with the production of NO2. Okay, so the NO2 will be substituted because in a benzene ring, this basically attached with hydrogen, 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 and hydrogen. All right. Okay. So one of the hydrogen, for example, on this side, gonna be substituted with NO2. So you know that this is a nucleophile and this is the electrophile. So it's gonna be electrophilic aromatic because it involves aromatic compound substitution. All right. Okay, I think that's all for today's video. See you again some other time. Bye.